Hello. In this problem, we have two batteries, and if you look at them, they are not helping each other. It is a single loop circuit. So the minus is on the minus, so they are not helping each other. Even you can follow E1 and E2 arrows in red, they are not helping each other. So we have all the constants, E and R, and the question is to find the current in the loop. Okay, you can choose either counterclockwise or clockwise, but both will end with the same result. So if you choose the counterclockwise, we have two rules to remember. If the loop is going with the EMF, I put plus for the E. If it is going against the EMF arrow, we put negative E. Now the rule concerning the resistor is very different. If the loop is going with the current assumed in the resistor, it is negative Ri. If the loop is going against the current in the resistance, it would be plus Ri. Now, if you apply these two rules for EMF and resistors rules, you will find that the loop is going with E1, so plus E1. Okay, and then you assume the current flowing from counterclockwise as well. So bill R2 it is going with the current, so I put minus I R2 minus I R1, and since the loop is against E2 I put negative E2 equals 0. I take I common factor لأنه same current لأنه هودي كلهم are in series, then I will have 0.5 ampere. Since the calculated I is positive, it means that the assumed current's direction is correct. In part B and C, they need the energy transfer rate. When we say energy rate, we don't mean energy, we mean power. So in the resistor 1 and in the resistor 2. هلا الباور usually هي U times I يعني voltage times current. But since هون الفولتج هو RI, I can apply Ohm's law, so I can replace by RI squared. Now, the power for the battery here, I times the voltage, 6 watt for 1 and 3 watts for 2. The 6 watts are supplied by the battery to the circuit, it is delivering energy, and the other one is acting as a receptor of energy. It is absorbed by the battery too, the 3 watts. In this problem, the two batteries are helping each other لأنه same direction لل EMF مثل ما بتعملوا أنتم باللعبة بتحطوا البطاريات plus minus plus minus. So both are generating energy to the resistor R. And one of them will lose all its energy at a certain moment وبيصير potential difference تبعها is zero. هلا هي عم تصرف على حالها هيدي الباتري resistance R small r اللي هي internal resistance, and we have the small r values and the EMF. The only unknown in this problem هي big R and I current. So since I have two unknowns, I have to think about two equations. أول equation هي loop easy. The second equation صراحة هي مخبية بقلب السنتنس اللي هي بالبارت A بالquestion what are values makes the terminal to the terminal potential difference of one of the batteries zero. So let's put some points ونقول إنه U of these 2 points of one battery is zero. But before starting any calculation, think about it. Both batteries are 12 volt. بس في وحدة عم تصرف على حالها resistance internal 0.016 and the second one R2 equals 0.012. So إذا حدا حيخلصوا مصرياته قبل نحن we made the analogy of إنه ال EMF هي created مثل المصاري. Okay, and then I have to consume a little bit على electrodes of the battery لأنه بيحموا كمان بيعملوا Joule effect. So عم يصرفوا على حالهم، كل بطارية عم تصرف على حالها. So في وحدة عم تصرف with a resistance 0.016 والتانية 0.012. أكيد ال E1 حتخلص قبل. So ال U of battery 1 should be 0 before ال U تبع الباتري 2. وال U of a battery هي ال EMF minus RI لأنه she is creating an EMF but it is consuming RI. Small RI I mean. So let's point points P, A, N. Okay. So UPA هي 0 okay, and UPA هي E minus R1I. I have only one current in this loop, so بتقولوا لي E minus RI. So I can say إنه ال EMF1 اللي هي E1 is equals to R1 times I. هلا I will not put values لأنه I will substitute it in the second equation. Now remember that from the previous slide we know that E equals R1I. But EMF1 is equals to EMF2 بالصدفة in this problem. So now in red I put E1 equals to E2 equals to RI. And then I go to the loop, I apply the Kirchhoff rule, and then using the clockwise direction بقول له E1 plus E2 minus R1I minus R2I minus RI equals 0. هلا they will cancel out and I replace everything by R1I لأنه ما بقى بدي أشوف لا E1 ولا E2. I replace them by R1I and then I can express big R in terms of R1 and R2. The final answer is R equals R1 minus R2 after you cancel out all these uh, uh, common numbers. Okay, in this problem we have two loops. We have the EMF1, R1, R3 هن left loop. On the right loop I have the EMF2, the resistor 2 and the resistor 3. Now you have to assume some directions for the current, okay, and according to your assumption you will start your calculation. Okay, since the question is to find the current in the resistors, so we have three unknowns: I اللي طالعة من الباتري 1, ال I2 اللي طالعة من الباتري 2, and finally ال I3 passing through the resistor R3. هلا which current is passing through R1? I1. Which current is passing through R2? I2 and I3 in R3. So when I am applying Ohm's law, please pay attention which current is passing through which resistor. Three unknowns, I need three equations. I will use two loops and one joint اللي هو I3 equals I1 plus I2 لأنه ال coming currents على الجوينت اللي بالنص is I1 and I2. The only outgoing current is I3. So you say IN equals I out. And then you apply loops. For example, on the left loop, you have an EMF1 going with the loop, so plus, minus R1 I1 and minus R3 I3. Again, on the right loop, you have EMF2 is going with the loop, so you put plus E2. The current is going with the loop, so you put minus R2 I2 and minus R3 I3. And then remember to replace I3 by I1 plus I2. So I only have two unknowns to equations. It can be solved يا أما using calculator يا أما you replace. The final answer is very strange لأنه I2 طلعت 0. So I3 is equals to I1, whatever that value is, and the current is positive 1.25 ampere. It means that the assumed current is correct.